Alright, so in this problem, we are given the work done by 1 mole of a monoatomic ideal gas and expanding adiabatically, and it's given to be 825 joules. We are given the initial temperature and volume of this gas, which are 393 Kelvin and 0.1 meters cubed. We want to find first the final temperature, and then we want to find the final volume of this gas. So obviously we're given the work, and we know since we have this monoatomic ideal gas, then this will be 3 over 2 nr delta T. So we're using this formula because we're given the temperatures and we're not given any pressures or volume. So now let's rearrange this to get T final. So delta T will be 2 over 3 W over nr. So T final will be T initial plus 2 over 3 W over nr. We have the work, we have the number of moles, R is a constant, and we have T initial. So we can now calculate the value of the final temperature. So the work done is 825 joules, N is 1, and R is 8.31. And this will give us 327 kelvins. In part B, we want to find the final volume. Now, we are told that this is an adiabatic process. So we can add to our formulas the formula for adiabatic processes. And if we rearrange this for V final, we get this. Now, obviously, we do not have the pressures, and we prefer to get rid of them. We can use the ideal gas law to rearrange the formulas of the pressures and put them in terms of temperature. So for P initial, we can write this as nRT initial over V initial, and for P final, this is nRT final over V final, and we have the initial power gamma here. So we can see that these terms cancel out, and if we solve this ratio, we will get T initial V final over T final V initial times V initial power gamma. So we can still rearrange and simplify. We should get V final power gamma over V final to be equal to T initial over T final, V initial power gamma over V initial, which will look like this. So this is our formula. We're given V initial, and we have the temperatures. We have T initial, and we just found T final. So all we have to do is substitute to solve for V final and find its value. Of course, we can put some radical here. To get the value of V final directly. So we know that T initial is 393 Kelvin. We found T final to be 327 Kelvin. And V initial is 0.1 meters cubed. So if we calculate these, we will get 0.132 meters cubed. Of course, this exponent here, you can just write it as 3 over 2. So this was the value of the final volume of our gas.